Dear students, welcome to virtual class of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 7th standard students. Subject is mathematics. Let me begin the class.
Dear students, we are entering into a new chapter, chapter number 14, Algebraic Formula and Expansion of Squares. A very important lesson and a very important learning will happen, which will be applicable in the coming classes for various situations. To understand this, you should recollect about the concept of area you studied and how to calculate the area of rectangle, square, etc. One previous knowledge required. Second previous or earlier information required is about the concept of factorization. We remember that if you ask about are the factors of 12, we will say that 4 and 3 are factors, 2 and 6 are factors, and even 2, 3, 4, 6, all these by which we can divide 12 considered to be the factors of it. You also studied about prime factors that also come into use in this chapter. So let us try to understand the concept of what we say the expansion form of especially certain expressions, algebraic expression. For that, here you are having a green rectangle. I would say I would like to name this rectangle first. Let me name the rectangle as A, B, C and D. I am having a rectangle ABCD. Let me put the name as ABCD. Now the thing is that I am going to divide this rectangle into 2-3 pieces. Before that, let me develop a corner square to this so that I can just remove that much. This is a square shaped portion I am removing from this particular rectangle. So the rectangle became a figure like this where I removed a particular part, and as I told you, as it is a square shape, I can mark this as x and this also x. So I removed x into x square from that. Right? We know that the area formula of a square is nothing but side square. In that case, I have removed side square x square from the given rectangle. When I talk about the area of that removed part, we have to think about the area of the remaining part. If this is equal to x and it is a square, this part also can be, it is also equal to x. That means this particular side I can mark as 2x, correct? So I could mark all these sides. Why I should stop from marking this? Let me mark this side as y. Here also it was y and this much is removed, and I can consider this as y minus x up to here if I mark it as e. These are all done for my convenience. Okay, then if I just want to make it a little bit, okay, let it be. Now if I think about the remaining of this, if I think that this is also a square having a side equal to, if I mark here this side, for example, here, from here to here, this also will be x, correct? Let me mark it as x. I need some other color, otherwise you cannot see that. Let this 2 be x, here also x, right? And let us mark this point as f and g. If I ask you what is the area of the remaining portion, this will be equal to x into x square. What is removed is also x square. This part is equal to, suppose length is equal to y and this much is y minus x, correct? And this is also y minus x. So I am having two part here. This is x square part and this is another rectangular part, but originally it was ABCD and half having a length equal to y and breadth equal to 2x, and the area of that ABCD will be equal to length into breadth, that is y, which is length of the given rectangle, and x into 2, that is 2x, not x into 2, 2x, which is equal to breadth. So total is 2xy is the original area of ABCD, the rectangle. What I did was I just removed this part. That means the remaining area of the, I can say area remaining or area shaded, area remaining can be written as 2xy minus x square. This much is removed, correct? This way we can calculate the remaining area. And if I think in another way, if I consider take this area of this one and take this area of this one, the total will be equal to the area remaining. So in that case, what is the area of this particular part? We can say the part can be named as ADEH. Let me mark it as such, plus the area of this small square. So I can say area of rectangle ADEH, what I would say, length is equal to y minus x, correct, and breadth is equal to, this is 2x. So length into breadth will be written like this. Then you have to add this particular x square to it later. So this one is equal to 2xy minus 2x into x, 2x square, plus the x square of this one. So what will happen? 2xy minus 2x square minus x square is only x square will remain. So then also we get the same answer as our formula of the remaining area or formula of the green shaded portion. So why I did all these things? We were simply using xy, 2xy, x square, which are named as algebraic expression instead of numbers, to solve a situation like this, where we were applying the formula of the area of rectangle and square, and what we used is algebraic expression, and we are getting answer in the form of algebraic expression itself. For example, the first method we got 2xy minus x square, the same answer we got in the second method. In both methods we were using expressions to find the area of the given. The purpose is your chapter of expansion and algebraic expression, and as well as finding out the factors of an algebraic expression, are having certain connection with what you have understood now. Now let us really get into the concept of expanded form of the square, especially of a binomial. You studied about monomial, binomial, trinomial, polynomial, basic concept about it last year. So we will be applying that over here in order to understand the concept of expanded form of certain algebraic expression. Okay. Look at this figure. In order to explain the product of algebraic expression, or what we say as an expansion, we need to develop some practical method of understanding it. In the figure alongside, which is given over here, we can name this particular figure as, for example, PQRS. It is a square. PQRS. are S. But this square is having a peculiarity. It is made up of number of rectangles and square of different colors. It is made by me to make you understand otherwise. But if you say that it is a square, the square will be having its own side, and the side is x here, y here. That means x plus y is one side. Understood? This is a square, so this side is also x, and that means this is also a x, and this side is y of this square, so that means this side is y and this side is x. So ultimately this is a square having side equal to x plus y. So PQRS is a square, first condition. Second, its side is equal to x plus y. This much we know now. But it has been divided into 4 rectangles, of which 2 are squares, 2 are rectangles. That way we have divided it. That division has got its own importance. These are the 4 rectangles in that. 1, 2, 3, 4 within PQRS. And we know that sum of these 4 rectangles will be the area of the given square. So we will try to find out the area of the square PQRS by adding the area of rectangle 1, 2, 3, 4. That is the next task we are going to do. So consider rectangle 1 first of all, which is blue in color here. The area will be area of rectangle 1. I am writing it like this for you. We will say rectangle 1, the first one having side x and x over here, we'll write it is equal to x square. And that of rectangle 2, which is this, it is nothing but x plus x into y, xy. Rectangle, the third one, which is again xy. The fourth one, this one, having an area y square. So we got the area of all this, and if you write it, you will write it x square plus xy plus xy plus y square as the area of the given square PQRS. If you rearrange it, it can be written as x square plus 2xy plus y square. What is it? Actually, the area of the square having side x plus y. So the area in that sense it will be x plus y whole square. So this is x plus y whole square, which we can directly calculate. This is also by calculating the area of separate rectangles in there. From this we conclude that x square plus 2xy plus y square is the expanded form of the expression x plus y whole square. If you are writing a plus b whole square here, you will be writing a square plus 2ab plus b square. That means a plus b or x plus y, which is a binomial, by squaring it, we get an expression which we have got now, and it is universal and it is true. Or we can say that it is an expanded form of this particular binomial when squared. Having a lot of application which I will be explaining to you within the chapter limit after explaining about another situation. What is the another situation? The same square. But the approach is slightly, we are going to change the approach of it. Let me show you. once again the same square. But the difference is that I have removed the measurement of the side. The measurement is same, but the representation I am going to change. Let me name this particular square once again as PQRS. Instead of naming sides as x plus y, I am going to put the side as A. The total side is A. But instead of x over here, I am writing B over here. That means this also will be B. Understood? If this is B, this will be B, and this also will be B. That means here this will be A minus B. This also will be A minus B. This will be B, correct? And this will be again A minus B. This will be A minus B. If you look at that angle, by considering the whole as A and this part as B, we can get this. Understood? And what we are going to think, last time we thought of the total area of the given square. This time, I am going to think in a different way. The same square, 4 rectangles, trying to find out the area of PQRS. But the naming of the side little bit changed. So let us consider the area of the first rectangle, rectangle 1, where the sides are A minus B and A minus B. So naturally it will be A minus B whole square. The second one, this is the second one, area will be A minus B into B. The third one, which is this one, again it will be A minus B into B, because we are applying the formula length into breadth. The fourth one, the answer will be B square. Altogether, it will make the area of the rectangle, square here, PQRS. We are finding the area. We also know that PQRS is having a side equal to A, so the total side, the area will be calculated by the formula A square also. This also we know. That means if I sum up A minus B whole square plus A minus B into B plus A minus B into B plus B square will be equal to A square. Understood? I can just expand this. A minus B whole square, A minus B into B means AB minus B square plus, what happens here? Again, AB minus B square plus B square is equal to A square. If you look at this, AB minus B square, AB minus B square. These two are positive, so you can write it as A minus B whole square plus 2AB, 1AB here, 1AB here. Now what we can see, minus B square plus B square. These both get cancelled and minus B square will remain, which is equal to A square. So if you think about the earlier case of x plus y whole square, here if you are thinking about this particular first, what we say, square, if I keep it along a side, if you simply think about A minus B whole square, this one, taking all to the other side, we will be forced to write A square, the same one, plus 2ab will become 2ab here, minus 2ab, minus b square will become plus b square. So in the last screen and this screen, we got two equations. Last screen we got a plus b whole square is equal to a square plus 2ab plus b square, and a minus b whole square is equal to a square minus 2ab plus b square. Then we developed two expansions of binomial algebraic expressions. First one was a plus b whole square is equal to a square plus 2ab plus b square. Now it is this one. Now it is a minus b whole square is equal to a square minus 2ab plus b square. My dear students, keep this particular expansion in mind because it is having great applications. And it is true, we can prove also. We can prove it is true. I will show you some example with respect to proving it. Please wait. Two expansions we got. First one was a plus b whole square is equal to a square plus 2ab plus b square. And now a minus b whole square is equal to a square minus 2ab plus b square. Let us think about certain practical situation in which this will be applicable. So, application of it. If values of a and b are given, simply substituting and getting answer is a very simple thing. It's simple explanation. I would like to tell you that if you are asked to find out the square of 51 square, 51 square normally we do like this 151. Then 5 ones are 5, 5 5s are 25. Correct? We do it like this. Right? If it is given in this format, and if you remember about this formula, why can't we write it like this, 50 plus 1 whole square? If it is 51 plus 1 whole square, why can't you convert that into this format? 50 square plus 2 into 50 into 1 plus 1 square. 50 square is 25 and 00. 2 into 50 is equal to 100 into 1 is also same, plus 1. And the answer is 2601. Understood, my dear students? If you are simply asked to find out if a is equal to 5 and b is equal to 3, and then what is a plus b whole square, in that case you will write that a square is 5 square, 2ab means 2 into 5 into 3 plus b square is 3 square. Understood? Which is equal to 25 plus 2 5s are 10 into 3, 30 plus 9, which is equal to 64. This is not a big thing, but this is a big thing. Why it is a big thing? There can be a situation where you have to find out the square, 98 square. You will write a 98 square means 100 minus 2 whole square, and you will equate it with a minus b whole square. That means 100 square minus 2 into 100 into 2 minus 2 square, and you will write that this 100 square is equal to 100 and 00. This is equal to 200 into 2, 400, and minus 2 square is equal to 4. That means from 100 square you have to minus 400. You will write it like this, right? You will write it like this. Then subtract plus 4, not minus, plus 4. Here it is plus, sorry. So plus 4 you will write here, and your answer will be 960. So simple. No multiplication big. So such applications are there. You are having a problem set, a practice set number 50 now, which you will be doing as a fun and will enjoy the concept of expansion of formula forever. You will by heart it, learn it, apply it whenever it comes across. Understood? Okay, let me move ahead. Before that, let me remove this. Now think about expansion of the given algebraic expression a plus b into a minus b. How can we imagine about it? A plus b into a minus b. We know that means with a we should multiply a minus b, with b we should multiply b minus a minus b. Right? We will write it like the a into a minus b plus b into a minus b, correct? Which is equal to a square minus ab plus ba minus b square, which is equal to a square minus b square. This is also a binomial expression of which expansion is a plus b into a minus b. So we got the third expansion. Why third expansion? Earlier one was a plus b whole square, second one was a minus b whole square, now it is a square minus b square. If I write it together, it can be expressed like this: a plus b whole square. I will change the ink so that you can see it more differently. You will understand. A plus b whole square is equal to a square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. Now it is a square minus b square is equal to a plus b into a minus b. Remember all these 1, 2, 3 expansion of algebraic expression, which will be of great use tomorrow in different type of situation. Okay, my dear students, very important. You will use this n number of times in your higher classes in different situations. To solve difficult situations, simply supply the formula, expansion formula, and solve it. You will enjoy it. Not now, in coming years, but by heart this expansion. Let me go ahead. First of all, remove this. Factorizing algebraic expression is something which is remaining, which you will be getting some idea about factorizing algebraic factors. I told you at the beginning. We know that 15. We know that 15 is having the factors. Factors of 15 are 3 and 5. Why? Because 3 with 3 we can divide 15, with 5 we can divide 15. 3 into 5 is equal to 15 because they are factors. 3 and 5 are factors. So if it is given 3x, 3 and x are factors. If it is 5t square, then we will say that 5 and t are factors. And we get 5 into t, we get 5t square. And if it is 6ab square, you will say that 2 into 3 into a into b are the factors. The factors are obtained by dividing it, breaking it into simple fractions. Sometimes we use this to solve certain situation. Sometimes it will be factorizing binomial expressions. These are monomial, 3x, 6ab square, 15 are monomial, single term. Sometimes there will be binomials which need this kind of expression and factorization. Let me take an example. Binomial, factorizing a binomial. For example, if there is a binomial, this is taken from your textbook, 4xy plus 8xy square. This is a binomial. There are two terms, monomial, binomial, trinomial. तो आप पहले पढ़ा है. Now I'm going to factorize it. How I am going to factorize it? I have to find out common for both. For 4 and 8, we are having common 4 only. 4, we can divide 4 with 4, 8 with 4. For x and x, we are having x as common. For y and y square, we are having y as common. So we will think about taking out common and solving it. So let us take 4 first. If I take 4 out of this, then I have to write this became 4 into xy for xy, 4 into 2, 4 into 2, 8 into x, 8x into y square. So what happened? 4 and this became, this meaning here, na? So 4 and xy plus 2xy became two factors of it. Why can't you think about taking one more step? Where if I take 4x as one factor, the remaining factor will be y plus 2xy. Because 4x into y, 4xy, 4x into 2xy square, 8xy. So these are also, these two, 1 and 2 are also factors of this expression. This way we can find out the factors of any expression. Understood? If the expression is 9a square bc plus 12abc square, two different terms, binomial expression. If I try to find out the common for 9 and 12, it is 3 which is common. Then naturally to get 9 I should have 3 inside. To get a square I should have a square inside. Then b and c plus, in order to get 12 I need 4 over here. And then I will write a, b, c square. This is one way of writing it. If I think about ABC is there, why can't I write 3ABC outside? Then what is remaining? One more a will be there, 3a will be there for 9a square, 3a into 3a, 9a square. Then BC is already there, nothing more. Then 3 into 4, 12, this 12. ABC is there, common. C square is required, then one more c. So these two became two factors. This way we find out factors. Why I said this? Because this is required to solve certain sums in practice number 53, which we are going to do after this video. So in certain situation, you will be breaking the given expression. Otherwise, if it is given to solve a situation, I will rub this out. So this way we can factorize binomial. Let me clear this and explain you why such a thing is explained in your textbook. Oh, sorry. This is not here, our blackboard, not. Sometime it make me fool. Chalo, let me see. Okay, this much is cleared. So this can be clear now. Take. Now, suppose that if there is an expression like this, in order to write the expansion, you are asked to find out, factorize the following, and the question is p square minus q square. Immediately आपको आएगा s square minus b square जैसा है. So you will write p plus q into p minus q. No problem. Suppose the expression is a square minus 4b square. then there is a problem in that. You have to convert that into such a way that it should be a square format. I will show you. This should be written as a square by c 4b whole square nahi hai. We have tried 2b whole square. What happened? 2 square 4 and b square 3 square. So it became in the format of a square minus b square format mein aa gaya. Then you will write the answer as a plus 2b into a minus 2b. To write this, we practiced the factorizing the binomial. I will take one more example from your textbook. 3a square minus 27b square. ये आपको करने दिया है. So you have to convert that into in such a factor that you can apply a square minus b square. So what to do for that? There should be a square minus b square. 3 cannot have anything of like any a square. So we will remove the 3 out. Then we'll write a square minus 9b square. See, it became in the format of almost like a square minus b square. Even then, how will we write that? This can be written as 3 into a plus 3b into a minus 3b. Why a plus 3b and a minus 3b? A plus 3b into a minus 3b is equal to a square minus b square. What is that? B square here? 3b whole square. Correct? So that will solve the situation. 9b square can be written as 3 into a square minus 3b whole square. So factorizing binomial concept should be clear to you. Otherwise, the problem set number 52 and 53 are direct application of expansion of formula that just now you studied. What are the formula you studied in the expansion? I will write it once again because I know that this is very, very, very important in your study of mathematics till 10th standard and further. So what are the expansion of formula you studied? I repeat it once again. A plus b whole square is equal to a square plus 2ab plus b square. By heart karo. A minus b whole square is equal to a square minus 2ab plus, that is a difference, b square. Then you learn that a square minus b square is equal to a plus b into a minus b. Okay, my dear students. Thank you.
Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.